Hi, I'm Rob and welcome to this, our 17th lesson in the topic of trigonometry. And this lesson follows on directly from the previous one in that we're going to continue to look at solving trigonometric equations just as an extra tweak in these ones, okay, where there's a number in front of the variable. So we're looking at multiples of the variable here, right? So really there's only kind of two things that we need to take into account when we're doing that. The steps involved are exactly the same as they were in the previous question, right? So remember, if we were solving an equation like this, sine theta is equal to a half. We went through in the previous lesson the sequence of steps involved in doing that, finding your reference angle by removing the word sine here by taking the inverse sine of both sides, and then work out which two quadrants my answers are in, and then how big are the angles in each of those two quadrants. Okay, that's sequence steps. I'll be doing the very same thing here, that if there's a number in front of the theta, like sine 3 theta is equal to a half, I'll do the very same sequence of steps. Okay, I'll go ahead and find the reference angle, choose my quadrants, find the sides of my principal angles, and then I can deal with that 3 afterwards. So the 3 that we're introducing here can be dealt with afterwards. Now, the two things that 3 does, it means two things. Obviously, it means that when I get angles, they're values for 3 theta, not just theta. So when I get my angles, I have to divide both sides by 3 to get values for theta. That's pretty obvious, and most people won't forget that. But the other thing that does is it changes the number of solutions I'm looking for. Because remember, if you were dealing with this function here, right? Now remember, because you're dealing with the function sine theta, it looks like that. And remember, the period of that graph is 360 degrees. So if we're asked to find the angles between 0 and 360 degrees, the solution between 0 and 360, it's within one drawing of this shape here we're dealing with. Okay? And you can see if I go across from a half here, a half is up there, go across, you can see there's two solutions there. Okay, you can see one of them's the first quadrant, one's the second quadrant. We don't need to worry about that. But there's two solutions there for that one, right? Now, what about this one here? If you remember when we were dealing with trigonometric graphs a couple of lessons ago, we pointed out that, look, if there's a constant here, when you're dealing with a graph, it'll be your center line. And if there was a number in front here, it's the amplitude. It's how far above and below the center on your graph goes. But remember what this number here does. It affects the period. That the period of the graph, remember, is a full circle divided by that number there. So the period of this graph here would be a full circle, 360, divided by 3. So the period of this graph is 120. So now, if I was asked to find the solution to this equation here that lie between 0 and 360, what would the graph look like? Well, if you think about that, what the graph would look like here is we get there's one shape there like that. That takes me up to 120, because the period is 120. We could then draw another one like this. That takes me up to 240. And then we could draw another one, a third one like that. So if I wanted to find the angles between 0 and 360, that's within 3 of these shapes. Because this number here reduces the period so we can get 3 of them. So again, if I go across from a half like that, you can see now there are 1, 2, 3, 4, 5, 6 answers. So not just do I have to divide the answers by that number there, but I have to remember that there's more than 2 of them. Okay, when I'm dealing with a number here, we'll have a look at whether there isn't 2 of them. The number will be different. Okay, if that number is bigger than 1, there'll be more than 2 of them. If that number is less than 1, there'll be less than 2, depending on the range you're dealing with. So the best way to kind of illustrate that is to show you a question. Okay, to take you through an example. So if you look at the question on page 255, the first one here, we're asked to solve this equation here. It's cosine 3 theta is equal to 1 over root 2. And again, we're looking for the answers between 0 and 360. Okay, so we're in degree mode here. So what I'm going to do for the moment, just ignore that 3 till the very end. So if you're solving a trig equation, just ignore any difficulty on the left-hand side. You've done your 3 basic steps. Find your reference angle, choose your quadrants, and then work out how big the angles are in those 2 quadrants. Okay, so we remove the word cosine first of all. So we get 3 theta is equal to the inverse cosine of 1 over root 2. And I pop that into my calculator and I get 45 degrees. So 45 degrees is my reference angle like we met in the previous lesson. Now, because I'm dealing with cosines, and my little circle looks like this. So the pluses are on the right and the minuses are on the left. And because here's a positive number, it's these 2 quadrants I'm dealing with. Quadrant number 1 and quadrant number 4. So it's going to be 0 plus the angle in here and 360 minus the angle like that. So we'll get here that 3 theta is equal to 0 plus the angle, which is 45 degrees. And then 3 theta is going to be equal to 360 minus the angle, which is 315 degrees. So there's our same 3 steps as we would have done previously. That never changes, right? So you can see here clearly enough from the line I've written down here that these are both values for 3 theta, because I haven't dealt with that 3 yet. So now if I divide both sides by 3, so divide across by 3 here, I get that theta is equal to 15 degrees. And divide both sides by 3 here, I get that theta is equal to 105 degrees. So obviously once I've got my 2 angles, I've got to divide by that number there to get values for theta. And most people will remember that. But they won't always remember what we mentioned a moment ago, that not only do the answers have to be divided by 3, we have to take account that there may not be just 2 of them. There may be more or less than 2 of them, depending on whether the number there is bigger than or less than 3. Or sorry, bigger than or less than 1. So the key idea here now is I want to work out what the period of the function is. Right? So what's the period of this function? Well, remember, to find the period of a function, you divide a full circle by this number here. We've met that now in the previous couple of lessons. To get the period of a trigonometric function, you divide a full circle by the number in front of the x or the theta or whatever the variable is. Right? So in this case here, the period of this graph is 360, full circle, divided by that number there, divided by 3, which is 120. So what that means now is solutions to this equation here repeat themselves every 120 degrees. They repeat themselves more often, right? Which means there's probably going to be more than just those 2 in here. So all I got to do now to finish the question is say, look, these answers repeat themselves every 120 degrees. So just keep on adding 120 to these 2 guys here until I go outside the range I'm looking for, right? So look what that looks like. So let's add 120 here because the period of the graph is 120. So if I add 120 here, I get 135. That's fine. That's in this range, no problem. Add 120 here, I get 225. That's fine. That's within this range here. Add 120 there, I get 255. That's fine. That's in this range here. Add 120 here, I get 345. That's fine. Okay, that's in this range here. Add 120 here, and I get 375. So I've gone outside that range here, so I'm done. So if I add 120 here, obviously I'm going to get 465. I'm bust there as well. So all you're going to do when you're dealing with an equation where there's a number in front of the theta, just solve it like you normally would. Find your reference angle. Go ahead and work out what 2 quadrants the principal solutions live in, and then how big the principal solutions are in those quadrants. So get these 2 numbers first. Then obviously divide across by that number there to find your values of theta. I said most people remember that. But then work out what the period of the graph is by dividing a full circle by this number here, and then just keep adding that period to the solution you've got here until you go outside that range there so you know you've got them all. So there are my 6 solutions here. Okay, 15, 135, 255, 105, 225, and 345. Okay? So if you look at the question then on page 256, the next one, it says solve the equation sine 4 theta is equal to root 3 over 2. Again, for an answer between 0 and 360. All right? So again, we've got a 4 here. Let's just ignore that till we get our first couple of steps done. So we'll find our reference angle first. So take the inverse sine. 4 theta is the inverse sine of root 3 over 2. And my calculator tells me that the inverse sine of root 3 over 2 is 60 degrees. That's my reference angle. Okay? Which quadrants am I working with here? Well, there's my little circle. Because we're working with sines here, the pluses are on the top 2 and the minuses here. And that's a positive sine value here. So it's these 2 quadrants here, the first and second quadrants. So it's 0 plus the reference angle and 180 minus. Okay, just make sure you practice that because it's like second nature. So that means that 4 theta will be 0 plus 60, which is 60 degrees. And 4 theta will also be 360 minus 60, which is, so it's 180 minus 60. Okay, which is 120 degrees. Right? So there are my 2 values for 4 theta. Divide across by 4 now, which most people remember. So theta is equal to 60 divided by 4 is 15. And 120 divided by 4 is 30. So there are my 2 basic solutions there. So I found the 2 principal solutions here, then divided by 4 to get the values for theta. Now remember, not only does the 4 mean I've got to divide my answers down, okay, but it also changes how many of them there are. So let me find the period of this graph here. So with the period, again, we're dealing with degrees, so a full circle is 360, and I divide by that number there. So if I divide 360 by 4, I get 90 degrees. So the solutions to this equation here repeat themselves every 90 degrees, not every 360, because of the change in period caused by that number there. So all I got to do now is keep adding 90 to these two here until I go bust. So add 90 there, I get 105. That's fine. Add 90 here, I get 120. That's fine. Add 90 here, I get 195. That's fine. Add 90 there, I get 210. Yep, that's okay. Add 90 there, I get 285. Yep, that's fine. Add 90 there, I get 300. That's fine. Add 90 again, I get 375. No use. So if I add 90 again here, I go outside the range 0 to 360. So there are my answers. Okay, there's 8 solutions, and they're the answers there. Okay, so it might be just worth pausing the video there and trying the one on page 257. Okay, it's in radians, but it doesn't change your method. Just see what you make of that one there. See if you got the idea. Now, just a couple little things in this one, okay, because it's a tan function I'm dealing with. Okay, so just something that you might not have spotted, but it doesn't really have a lot of impact on your solutions. So again, there's a 3 in front of the theta. Let me just ignore that for the moment and say, look, I'll get the inverse tan. So theta is the inverse tan of root 3. And again, I'll put my calculator into radian mode here because we're trying to give our answer in radians, and it comes out there as 1/3 pi. That's pi over 3. Okay, that's my reference angle. Okay, so which quadrants am I dealing with here then? Well, because I'm working with tans, the tan rate this time, my circle looks like this: plus, minus, plus, minus. And because it's a positive tan value we're dealing with, it's these two quadrants here. So it's 0 plus the angle and pi plus the angle. Okay, so it's 0 plus or 180 plus are the two if they were in degrees, so 0 plus and pi plus here. So that means 3 theta is equal to 0 plus pi over 3, which is pi over 3. And then 3 theta is equal to pi plus pi over 3, which is 4 pi over 3. There's my two solutions, right? Now, obviously what I got to do now is divide by 3. So when you divide by 3, you just basically multiply the number below the line by 3. You don't need to know that. Your calculator will do it for you. But if you want to save yourself a trip to Captain Casio, all right, if I divide by 3, it's the same as multiplying by 1/3. So when you multiply by 1/3, you multiply the top by 1, the numerator, and it doesn't change, and the bottom line by 3. So if you're dividing by 3, you multiply the denominator by 3. If you're dividing by 5, you multiply the denominator by 5. So theta then is pi over 9, and theta is 4 pi over 9. Okay? So there's my two basic angles. Now, the period here, right? So if you remember here that the period of the tan graph is not quite the same. A tan graph repeats itself every 180 degrees, every pi radians. Okay, that's the period of that graph. Now, let's just say I forgot that. And I say, look, anytime I do that, I'll just divide a full circle by 3 to find the period here. So I would say, look, the period of this graph, okay, is, let's say we say it's 2 pi divided by 3. It's a full circle, 2 pi, divided by that number there. It's 2 pi divided by 3, right? So that's my period there, all right? So what I'm going to do now is I'm going to just keep adding 2 pi over 3 to this guy here and this guy here until I go bust, until I go outside the range given the question. Now, that's a little bit hard to do because I'm comparing fractions here. Okay, so what you could do, and I'll show you this in the next question where it's a little bit more relevant, okay, if you want to save yourself a little bit of time, you don't have to do this, but just to make life a little bit easier, all right, if I turn this into ninths, so because the denominator here is 9, if I want to put this over 9, just multiply top and bottom by 3, multiply below the line by 3, I get 9, multiply above the line by 3, I get 6 pi. So 2 pi over 3 is the same as 6 pi over 9. Now that'll make adding the period to these numbers here very easy because they've got the same denominator. So because that's something over 9, I can just add the numerators. I can do it using my calculator and leave it as 2 pi over 3 if I want to. But if I want to speed myself up, let me just get a common denominator here. They're both over 9. So all I'm going to have to do to keep adding the period here is just keep adding 6 pi above the line. So add 6 pi, you get 7. Add 6, you get 13. Add 6, you get 19, and so on. Right? And let me put this guy over 9 as well, so I'm comparing like with like. Okay, so 2 pi over 1, if I multiply top and bottom by 9, multiply that by 9, I get 9, and multiply that, I get 18 pi over 9. Now, if I just, whatever the number below the line here and here is, if I put the period and the end point of the range over the same number, By just multiplying top bottom by whatever I do to make that the case, it makes it very easy to add the period here and here, and it makes it very easy to see when I've gone bust. So let me show you what I mean by that. So if I want to add 6 pi over 9, I just add 6 above the line. So I get 7 pi over 9. That's fine. We're not bust yet. Add 6 here. I get 10 pi over 9. That's fine. Add 6 here. I get 13 pi over 9. That's fine. Add 6 here. I get 16 pi over 9. So see, I just have to keep adding 6 pi above the line because the denominator is already the same. So that speeds me up. Okay, I can do this very quickly now without having to reach for my calculator. I can do it with my calculator all day long if I want to, but I don't have to. That's why radians are helpful. And you can see now at a glance, I can see whether I've gone over this number now, because if I add 6 here, I get 19 pi over 9. I've gone bust. They're my solutions. And they're the 6 correct answers. Right? So there's my 6 solutions there. Now, if you notice here that that's actually not the period of the tan graph. The period of the tan graph is pi. Because the tan graph, remember, it's the weird shaped one that repeats itself every 180 degrees, right? So if you said, look, the period is pi divided by 3. Okay, so the period is actually pi, and then divide the full period pi by that number, it's pi over 3, which is basically just, if I multiply top bottom, it's just 3 pi over 9. Do you see what happens if that's the case? If I say, look, it's 3 pi over 9, if I add 3 pi to that one, I get this guy here. Add 3 pi to that one, I get this guy here. Add 3 pi to that one, I get this guy here. So I'm just going to produce the same answers anyway. It's not going to have any bearing on my calculation. So although the period of the tan graph is pi, and you'll see it done that way, okay, there's nothing wrong with doing it this way. Okay, it's just say, look, we'll just take a full circle, divide by that number there, okay, and just keep adding that to the 2 solutions I've got to get the answer I'm looking for, all right? If I did say the period was pi over 3, I will produce the same list of numbers. There's no problem there at all. So that's a good example, that one, okay? So it might be worth pausing the video there now and then trying the one on the next page. The one on the next page is a good tricky example there. If you can do the one on the next page, you're probably thereabouts in understanding how to solve a trig equation. Okay, so here's the one on page 258. Sine 6. Oh, 6. 6 theta is equal to minus a half. Okay, and we're working in radians. So everything that can go wrong here has. Right, we've got a minus sign here, we've got a number there, and we're in radians. So he's literally thrown everything but the kitchen sink at me here. This is shock and awe. Okay, so everything has been hurled in my direction here. So if I can deal with this one, there's really nothing he can throw at me that I wouldn't be okay with. Okay, so as usual, let's just worry about the 6 in a moment. Let's not get too bogged down in that now. First of all, find your reference angle. So 6 theta is the inverse sine of a half, remember? As we had in the previous lesson, I don't need to take that minus sign here. That minus sign will just tell me which 2 quadrants my answers are in a moment. I don't need to deal with it here. So the inverse sine of a half, if I pop it into my calculator in radian mode, is pi over 6. There's my reference angle, all right? And then remember, because I'm dealing with sines, whereabouts in the circle am I looking here? Well, my sine circle looks like that. The top 2 are positive, bottom 2 are negative. And because we've got a negative number here, it's these 2 quadrants. That's the only relevance of that minus sign, which is why I can ignore it at this stage here. That minus sign just tells you which 2 quadrants my answers are in. So it's the 3rd and 4th quadrants. So it'll be pi plus the angle here and 2 pi minus the angle there. Just make sure you're very clear on that. Okay? So 6 theta here will be pi plus pi over 6, which is 7 pi over 6. And then 6 pi will be 2 pi minus pi over 6, which is 11 pi over 6. Okay? So there's my two principal values there. And now, as usual, let's divide across by that number there to get values for theta. And if you're going to divide by 6, you just multiply them below the line by 6. You can do it using your calculator if you really need to. But to divide by 6, I just multiply the denominator by 6. So theta will be 7 pi over 36. And theta will be 11 pi over 36. So there are my 2 basic answers there, right? So now, in addition to that, I need to remember that there's more than one answer. Because that number there is bigger than 1, there's more than 2 answers here. So I'm going to need to find the rest of them. So again, let me work out what the period is. So the period of that graph, remember, it's a full circle, 2 pi, divided by this number here. So it's going to be 2 pi divided by 6. Which is simplified to pi over 3, but there's no value in doing that here, okay? Because remember, like I did in the previous question, because I'm going to be adding the period to these numbers here, and these guys here have a denominator of 36, Let me get this one over 36 as well, so the denominators match, so it's easier to add. Remember, when you're adding fractions, you need a common denominator. So if I multiply top and bottom here by 6, multiply below the line by 6, I get 36. And multiply above the line by 6, you get 12 pi. So 2 pi over 6 is 12 pi over 36. So what that means now is to add the period to these angles here, all I've got to keep doing is adding 12 above the line. We've made sure the denominators match, so I just have to keep adding 12 above the line until I get to my range. And then let's do the same for this one here, so we know where to finish. So remember, 2 pi over 1, to get over 36, let's multiply top and bottom by 36. Multiply below the line by 36, I get 36. Above the line by 36, I get 72 pi over 36. So all I'm going to do now is keep adding 12 above the line, because that's my period, until I get to 72. So if I get into the habit of doing that now, I don't even have to reach for my calculator at all, okay? So let me just start adding 12s here. So add 12 there, we get 19 pi over 36. That's fine. Add 12, we get 31 pi over 36. That's fine. Add 12, we get 43 pi over 36. That's fine. Add 12, I get 55 pi over 36. That's fine. Add 12, I get 67 pi over 36. That's fine. Add 12, I get 79. I'm gone bust. Okay, so they're the only solutions I can produce from that one, right? What about this one? Add 12, I get 23 pi over 36, right? Add 12 again, I get 35 pi over 36. Add 12 again, I get 47 pi over 36. These are all fine, all right? Add 12, I get 59 pi over 36. Add 12, I get 71 pi over 36. And if I add 12, I get up to 83. I'm gone bust. So there are my answers there. And there's the 12 solutions. So that's a really difficult question with lots of solutions. But if I get into the habit of using radians that way, I mean, obviously I don't need to do what I did there. I could just keep adding 2 pi over 6 to this guy here using my calculator. I can certainly do it that way. It's just a little bit trickier to know when I've got them all. So when I'm not comparing it to. So what I would tend to do with these ones, as I've done here, is once you've got these two angles here, you've divided across by that number, you've got these two angles here, work out what the period is by dividing a full circle by this number here, all right? And then put this over the same denominator you have here. So multiply top and bottom here by whatever you've got to do to make that number match this one. And then once you've got the common denominator, all you've got to do then to add the period each time is just keep adding that number above the line. So I just have to keep adding 12 upstairs. 7 plus 12 plus 12 plus 12 plus 12 and so on. That's how I add the period. And so I know when I'm done, okay, I would put this guy over the same denominator. So put that over 1 and then multiply top and bottom by whatever you got to do to make the number below the line the same as this one here. So you can see once I've done that, I know I just have to keep adding 12 above the line until I get above 72. And the question becomes much, much easier if I do it that way. Okay, so we'll just maybe have a quick look at the final question there just to bring us up to the end of that lesson. The one on page 259, maybe not quite as difficult. So our final equation, this one here, question 17.5 on page 259. It says solve the equation tan 3 equals minus 1 for theta an element of 4 and theta in degrees. So again, notice we're not given a range here, we're given, he wants them all. So we're going to have to give him our general solution here for this one, okay? But again, all of that we can worry about at the end. We'll just do our usual 3 steps which never change, right? So let me get the reference angle first of all. So 3 theta is the inverse tan of, remember I don't need to bring the minus sign with me, it's the inverse tan of 1, okay? And that, if I put that into my calculator in degree mode, because he wants 10 degrees, that's 45 degrees. That's my reference angle. And then whereabouts in the circle are we looking here? Well, because we're dealing with tan values here, it's plus minus. And because you've got a negative number here, it's the second and fourth quadrants we're dealing with. So it's going to be 180 minus the angle here and 360 minus the angle here, okay? So 3 theta is equal to 180 minus 45, which is 135. And 3 theta will also be equal to 360 minus 45, which is 135. Okay, like that. So there we go. Which is 315. That's 135. All right, so there's my two basic angles like that. All right, and then they're the both values for 3 theta. Divide by 3. So we get theta is equal to divide that by 3. We get 45 degrees. And divide that by 3, theta is 105. So there's my 2 basic angles. Now remember, he wants them all, right? So there's no way I can write them all because there's an infinite number of them. So what I want to do now is work out what the period is. And you can, as we said previously, we're dealing with tan values, that the tan function repeats itself every 180 degrees. But let's say I don't want to worry about that. Let me just say what I'd normally do. Normally, how would I find the period? I take a full circle and divide by that number there, right? So if I said, look, a full circle, 360 degrees divided by 3 is 120, right? So these answers repeat themselves every 120 degrees, okay, is the basic idea here, all right? So if I take this one here, for example, so look, if you want to get answer, it'd be 45 degrees plus n times 120, not n times 360, n times 120, because that's how often this function repeats itself, okay? And then 105 degrees plus n times 120 there as well, okay? They're the two values, okay? And again, I'll put down my n, an element of z like that to remind myself that that's the case, okay? That's what we're dealing with. Now, just notice here, that because that would produce all the answers. I can actually simplify that if I spot it. There's nothing wrong with that. That'll produce all the answers I'm looking for. But if I said, look, I remember that the period of a tan function is 180, right? So I said, instead of going 360, I said, look, it's 180 over 3 is a period of 60 degrees. So this graph repeats every 60 degrees. So you see what would happen if I wrote it down that way? I'll take this guy here. So you've got 45 degrees plus n times 60, okay? And then this one here, 105 plus n times 60. But notice here, if you add 60 to that, you get 105. And if I add 60 again, I'll get this, I'm just going to keep switching between them here. So if I'm just going up in 60s, that second one there is irrelevant because it's going to include all of these angles as well here. So if I add 60, I'll get this number here. Add 60 again, I'll get the next one on this list. Add 60 again, I get the next one on this list. So if I'm going up in 60s, I'll get all of them in just one go. So I could write the answer that way as a single solution. It's just 45 degrees plus n times 60, but that will cover them all as well. Right? So if you do remember that when you're dealing with a tan function, the period's not 360, it's 180. Very often it'll mean that you can just give it as one solution that way. That's a better answer. But there's nothing wrong with that one. That would produce all of the same correct answers. Okay, that'll cover you completely. Right? So that's how we deal with numbers in front of the theta. Okay, and that's the one to make sure you can do. That's a much better exam question. And when there's a number in front of the theta, it just makes you think a little bit more, gives you a little bit more to work with. Right? So in the next lesson, our final one on trig equations, we're going to have a look at ones where essentially you're going to have to try to get to this point first. That equation there is kind of concealed from you, and we'll have to use formulas or factorization to get there. So we'll have a look at those in the next lesson.